Hi, today we'll be discussing section 3.7, the sum and difference of cubes, and a general approach to factoring. In this video, we'll be talking about the sum and difference of cubes formulas. We'll also go over problems number 1 through 8. When you think about factoring and you have two terms, you'll likely have a special pattern. We've previously talked about the difference of squares when you have two squares. In this section, we see the difference and the sum of cubes. So we have a special pattern to help us. A cubed plus B cubed is A plus B times a squared minus ab plus b squared. There's that same pattern for a cubed minus b cubed. It's a minus b times a squared plus ab plus b squared. If you can figure that out, that the middle term is just a and b, so ab, and the first term is a squared and b squared, and then a plus b or a minus b. So you have to memorize these formulas, so find a way to see that pattern and make a connection. Remember to use SOAP when you're dealing with the signs. So if it's a cubed minus b cubed, then the first sign will be the same as the minus. The next sign will be opposite, and then the third sign is always positive. SOAP. Let's try it. Look at problem number 1. What is step 1 when we factor? Take out the GCF. We can't throw that out. We've got to use that. So, is there anything I can factor out? No, I'm done. Next, I count the number of terms. There are two terms, so I must have a special pattern. Is this the difference of cubes or the sum of cubes? Is this the difference of squares? Which pattern do I have? So I notice it's the sum, and we cannot take the sum of squares, so I hope it's a cubed. And I notice that x cubed and 125 is something cubed. The first step here is to take the cube root of each piece in order to find a and b. What is the cube root of x cubed? So here, a will be x. What is the cube root of 125? 5. So b will be 5. Once you know your a and b, you just plug it in to your formula, which you have memorized. So you can see it here, but for your exams, you'll need to know this. I have x, same sign, plus 5, times x squared, so same, opposite, like you can see here, same, opposite, and then ab, so 5x, and then always positive, plus b squared, 25. That's it, you're done. You have factored that sum of cubes. Let's try it again. Step 1, is there a greatest common factor that I can take out? No. Step 2, count the number of terms. Since there are two terms, it's a special pattern, and I notice that they're both cubes. So I take the cube root to find a and b. Here, a will be 3m, and b will be 4. Then I just plug it into my pattern, and you're set. So 3m minus 4, same sign, and then 3m squared. Don't forget to square the 3. So that would be 9m squared. Opposite, so plus, and then multiply these together, so 12m, and always positive 4 squared, which is 16. And that's it. Let's look at number 3. Is there something I can factor out? Yes, you can factor out an 8. Factor out the GCF first, or it won't be considered fully factored. So I can take out the 8, and I'm left with t cubed minus 1. When I take out that 8, I'm dividing each term by 8. 8t cubed divided by 8 is t cubed. 8 divided by 8 is 1. Now I can take the cube root of each of these pieces and find a and b. So a will be t and b will be 1. And plug it into my formula and I'm done. Don't forget the 8. That's still part of the factors. So 8 is a factor. and then I have same sign, so t minus 1, and then t squared, opposite sign, a times b, so just t, and then always positive 1 squared. Let's keep going. Is there anything I can factor out on number 4? No. So I go ahead and take the cube root of each piece so I can find a and b. A will be 10y, b will be 1. And now I plug this in. So 10y, same sign, plus 1. Then 10y squared. Don't forget to square the 10. So 100y squared, opposite sign, minus. Then you multiply the 2, so you take AB. So 10y times 1, and then always positive, plus 1 squared. Great job. Let's try a couple more. Look at number 5. First of all, is there a GCF I can factor out? No. I notice it's the difference of cubes. Since I have 2 terms, I know it's a special pattern. So I take the cube root of each piece to find a and b. And a will be 2x and b will be 1. Students often make mistakes with 8. They just leave it as 8. You have to take the cube root of 8 also. All right, now I plug it into my template and I'm set. So 2x, same sign, minus 1, a squared, so 4x squared. Don't forget to square that too. 4x squared, it's opposite, so plus. AB would just be 2x, and then always positive. 1 squared is 1. Let's do it again. Is there anything that I can factor out in problem 6? Nope. So now I notice it's 2 terms, a special pattern, and this is the sum of cubes. So I take the cube root to find a and b. A is 4m and b is 5n. Now I plug it into my pattern. So 4m plus 5n, same sign. And then the first piece squared. So a squared is 16m squared. Don't forget to square that 4. Then opposite sign minus AB, so 4 times 5, 20 mn, and then always positive b squared. Don't forget to square that 5, so 25n squared. Hopefully you're getting the hang of this and you're feeling more comfortable with the pattern of the sum and difference of cubes. Let's do the last one. Okay, is there anything I can factor out? Nope. Then I count the number of terms. Since there are 2 terms, I know it's a special pattern. In this set, we're studying about the difference and sum of cubes. But look at this problem. It is also the difference of squares. X to the 6th. You can take the cube root because 6 is divisible by 3. You can also take the square root because 6 is divisible by 2. Notice how special 64 is. You can take the square root and get 8, or you could take the cube root and get 4. So what do? In order to factor completely, you have to take the square root and the cube root. I would suggest taking the square root first. So let's take the square root of both pieces and find our a and b. Here, the square root, remember you're just dividing the 6 by 2. So this a would be x cubed and b would be 8y cubed. Now, the difference of squares is a plus b, a minus b. So then this would become x cubed plus 8y cubed times x cubed minus 8y cubed. Now we have the sum of cubes and the difference of cubes. Remember, it says factor completely, so keep going until you're done, until you have that product of primes. So I take the cube root now to find a and b. And in this case, a would be x and b would be 2y. And the same thing for our next piece. It's just the different formula for sum of cubes or difference of cubes. So take the cube root, and again, a would be x and b would be 2y. Now, I want to take the formula for the sum of cubes. So x to the 6th minus 64y to the 6th, completely factored, would then be, start right here and do the formula for the sum of cubes. So same sign, x plus 2y, and then x squared, opposite sign, minus, and then 2xy, always positive, plus 2y squared. So again, don't forget to square the 2. So 4y squared. Then you have the difference of cubes. Same idea, but the signs change. So SOAP. Remember, same, opposite, always positive. So here I'd have the same sign, x minus 2y, and then x squared. Opposite would be plus. Once again, multiply them together. So 2xy, and then always positive. Don't forget to square the 2. So 4y squared. Is there anything else I can do to factor? No. This is a list of primes. So I have the product of primes, and I'm done with number 8. I hope that was helpful. We'll see you next time.